Okay, sorry, there is a technical issues, so we've been scheduling 2, 3 timings actually. Sorry for the inconvenience. I would like to inform you that hopefully today we'll complete the 2 classes, which are small topics, so that we can complete IS 107 today, which is chemical safety. From next week onwards, we can start IS 108 construction safety. We'll wait for 1, 2 minutes to other people join, so we can start the session. Okay, we can start the session now. Yes, we can join. I don't want to wait. Almost 2 people are waiting, but since our last half an hour, uh, very sorry. Okay, fine. In last class, we were discussing about the modes of transportation of chemical. Then we discussed about the various checkpoints to be considered while doing inspections, and we have seen the sample inspection checklist. Hope I am audible and visible. I'm not asked while starting. If there's any issues, you just put in chat box. Okay. So today we are talking about the safe startup and the shutdown procedures. So what it mean by safe startup, shutdown? If you come across with the safe startup and shutdown, when it is happens, if you are doing any activity or your plant has been undergone for a long-term shutdown. So after a couple of months, you are starting your activity. For example, if you see any this thing, what do you call your reactors or ANFDs or any other chemical activity which is happens, you're taken for the shutdown. In the sense, your all batches are done. Now you took that equipment for cleaning. Then you are starting that equipment after a long duration. In such case, what will happen? You should follow some sort of procedures or practices to perform the activity in a safe manner. So if you see a startup or a restart operation after a long or short long-term shutdown, the shutdown procedure is in as special precautions, because we don't know what has happened during the shutdown, or sometimes maybe some kind of chemicals would have entered inside and we don't know the condition of the equipment during that time. అంటే ఏంటంటే ఏదైనా ఒక వస్తువుని లేదంటే ఒక పరికరాన్ని లేదంటే ఒక ప్రదేశాన్ని కొన్ని రోజుల తర్వాత మనం అంటే కొన్ని రోజులు దాన్ని ఇనాపరేషన్ లో ఉంచి మళ్ళీ దాన్ని ఆపరేషన్ లో తీసుకొచ్చేటప్పుడు మనకి సేఫ్ స్టార్టప్ ప్రొసీజర్స్ అనేది చాలా క్రిటికల్. If you see, the starting sequence should be well defined. What is meant by starting sequence? The starting sequence in the sense from where I have to start. What is my starting point? That has to be defined very clearly. Otherwise, what will happen? We can't able to do this startup in a smoother manner. Written and also known to the workers involved in this work, starting in sequence of utilities like water, air, power, purging, charging, slow and gradual heating, monitoring of the pressure, temperature, flow and reaction rate, cooling if necessary, starting of exhaust system, scrubber or condenser, etc., and observing noise, vibration, speed, and alignment, synchronizing, etc., are all important. So here the thing is, it should be well defined, written, and known to the workers involved in this work. The people are known to the activity what they are performing. And also the starting sequence, like maybe you may start from the water cleaning, then we check with the air, and we check with the power conditions, and we check with the purging in the sense inert gas purging, then charging of the metals, whether it is properly happening or not, then slow and gradual heating. So initially we'll start heating up of the vessel, then gradually we have to increase. We should not give sudden heating. And then monitoring of pressure, temperature, flow and reaction rate, and cooling necessary. Then we also need to check for starting exhaust systems, scrubber and condensers. So exhaust systems are properly working or not, we have to check. Then observing the noise, vibration, speed, alignment, synchronizing, etc., are all important. And also we need to check for the any noise which is generating or any vibration or any alignment issues. All these things has to be monitored during safe startup. Then during the startup of its drain remains open, vent valves remain closed. So wrong valves are operated, unwanted material centers. Example, oxygen instead of nitrogen or blanketing over flammable reaction. So we need to check for the all the drains remains open and the vents valve all closed. So wrong valves. So we have to see as per the sequence, and also valves to be opened as per the startup sequence which we have defined. Otherwise, what will happen? Maybe instead of, as an example, oxygen instead of nitrogen as a blanketing over the flammable reaction. And water, where it is incompatible, and air instead of steam or steam instead of air, or excess or less charging of the material or catalyst, and delayed cooling or heating, not starting any pump or instrument, no indication or alarm due to failure of malfunctioning of instrument in the beginning, no starting of local exhaust or scrubber when it is essential, and failure of interlock or trip resulting in unwanted mixing or reaction, mixing of air with hydrocarbons, and contracting hot oil or and water, thermal or mechanical shocks, etc. So these are some of the examples for possible disasters. Disorders in the sense mistakes. Instead of air, instead of nitrogen, oxygen will come. Instead of oxygen, nitrogen will come. Instead of small quantities, the large quantity of chemical will comes in. All this happens because of these small operations. Okay. Then attention should be paid on preparatory activities, verifying the content, removal of air or venting, purging and disposal of purged material, and the removal or addition of water, slow and sequential starting of the heating or cooling, gradual reaching of working parameters, and the normal operation. Sometimes what will happen, they keep it some kind of chemicals inside the vessel to maintain the condition of the vessel. So in case of such case, we will have to follow this procedure. Then slowly we have to heating the equipment or cooling the equipment to reach the working parameters. We can't directly take to the working parameters. Slowly and gradually, we have to bring it to working parameters level. Then another point, needing attention to start up a removal of shutdown blinds and providing running blinds, and opening of the scrubber or drainage line valve, and opening of isolation valve before safety valves, and starting of local exhaust ventilation, pump cooling, and priming readiness of the firefighting equipments. So for the new people, this will be a bit confusing. So what we are doing and all, the major thing is, whenever you are doing any startup, you have to remove the shutdown blinds. Shutdown blind in the sense, it is a kind of plate in between the pipe we put. So no material will pass into the equipment, I mean inside the equipment, or it will not go from equipment to other pipelines. These are the shutdown blinds, and it is an obstruction. And providing running blinds, maybe orifice we can say, like we'll have a parameter, or we'll put the valve in between. Opening of the scrubber in the sense, the scrubber line should be active. So in case of any escape of gases from the equipment, it will route through the scrubber line so that it can go and neutralize the things. Then leak detection, opening vents and drain before allowing steam in the system, and partial opening of the steam valves, and introducing steam from the bottom part, and observance of the level of the overflow if any, and safe increase in the loading, and avoidance of incompatible material, avoidance of moisture and impurities in breathing air, purging of blowdown tanks and flame, removing air from vacuum equipments, inspecting joints and valves for leakage, verifying steam traps, working for condensate discharge, safe displacement of steam and water, purge gas after their usage, and removing residual water before introducing any hot oil, then using heat exchangers. So if you see, this is the one of the most dangerous part. Sometimes what will happen? They'll have an hot water, then it has to be drained properly. Otherwise, what will happen? Hot water also is one of the utility we use for to heaten up our reactions. Then we also use hot oil because hot oil temperature is higher than the hot water temperature. Some of the reactions may require higher temperatures, so where we use hot oil. In such cases, we have to ensure that the hot oil uh, to be purged after removing of hot water or water from the condenser or the pipeline. Then shutdown. Till we have seen about the safe startup, now we'll see shutdown. So shutdown operations also so critical. Otherwise, what will happen once we done the shutdown, nobody will go there, nobody will look after that specific equipment. So if the things are not done properly, it will be resulting in a greater incidents. The shutdown operation needs a sequential steps like cooling and depressurizing and pumping out, removal of residual content, example hydrocarbons, corrosive or toxic chemicals, water, oil, and pyrophoric catalyst, disposal of effluents and sludge, drainage and blinding and isolation activities. So here mostly what will happen, the sequential steps. One is cooling. Definitely we'll do all the reactions with some sort of temperatures, maybe 10 degree, 15 degree, in a sense above the atmosphere temperature, in the sense 26 room temperature, 26 or about 60, 70. So the vessel has to come down to cooling. Then some sort of reactions we'll do with some pressure. So it has to depressurize. Then pumping out. So in case of any residue, which is there inside the reactor or the vessel what you are using, it has to be taken out. Then pumping out, then removal of residual content. Still, once you have done, once you have done removing of the content also, still there may be a residues that also need to be checked. Example, hydrocarbons, corrosives, toxic chemicals, water, oil, pyrophoric, catalyst, disposal of effluents, sludge, drainage, and blinding. In this sense, simply, first we have to cool down, and second we have to depressurize, and we have to pump out the content inside, and we have to do a cleaning. Clear residue in the sense, wherever it sticks in the corners or somewhere while pumping out, which is not clearly went out. Then heat source should be cut off, cooling may be continued till required. So then we have to stop the heat source. Whatever the heat source we have, that needs to be checked, we have to remove the cut off the heat source. Then we can maintain the cooling till it is required. And where the vacuum is possible, it is the cooling and inert gas or air, if compatible, should be introduced into the atmosphere pressure, pumping out metal after cooling and depressurizing. And the pump hot oil should be cooled below its flush point. Residual hydrocarbons can be removed by purging with steam, water, or water followed by the steam. So purging hydrocarbons in the sense, hydrocarbons will be there. Hydrocarbons will be remain there. So to remove those hydrocarbons, we'll do hot water or steam under the influence of purging conditions. For example, if the hydrocarbons are in flammable, highly flammable nature, so if I do directly, the evaporation state increase, it may leads to accident. So in such cases, what I do is I'll remove hydrocarbons by the hot water or steam under purging condition so that I can avoid the accidents. And after purging, the air should be allowed into the system and residual water should be removed. And lastly, running blinds should be removed and also shutdown blinds should be installed. So if you see here in the previous starting process, there we are removing the shutdown blinds and putting the running blinds. In reverse here we are removing the running blinds and putting the shutdown blinds because here we are taking the equipment for shutdown. And if the shutdown is required due to any fault or in the case of any fault should be found, studied and also removed before starting of the plant. That is about shutdown activity. Then maintenance is also one of the critical activity where we have to ensure while performing any maintenance activity. So if you see the maintenance should be considered as early as a design stage, and good engineering initially can reduce the maintenance problems considerably. So if the equipment is properly designed, there will not have a much major maintenance requirements. Those parts of equipment that needed frequent attention should be a good accessibility and be easy to remove or replace. Space must be available for the tools and special maintenance equipment such as lifting gear, jacks, or large torque wrenches. And the plant maintenance system is introduced and should include plant condition monitoring. It enables the state of the plant to be reduced vessel in the service and the cutting maintenance cost considerably compared to the trip down inspection methods. It is simple that you should have proper maintenance mechanism, like which is preventive maintenance, so that before the material or before the equipment goes on shutdown or accident, you are doing diagnosis. How, like once we go to the hospital, we do annually, yearly health checkups. How we do? So we go for examination, complete blood examination. Then doctor will do all the complete diagnosis. He will ask what your eating habits or sleeping habits and the working, how you are doing all these things. Then he will prescribe a medication. Then The same way, we should have a proper maintenance mechanism in place so that we can able to maintain the equipment in a proper manner. If any planned maintenance, then the condition monitoring system should be include a breakdown maintenance, repair and analysis system. This enables modifications to be made subsequently. Two such schemes may modify maintenance periods or adding or subtracting and other operations. Still will also help to identify the poorly designed or constructed plant and enable the better specification to the produced or replacement items. So the plant maintenance, which also includes the breakdown. While doing PM, you may find out some of the parts have been worn out or some of the parts have been damaged. So again, we have to replace those parts. It is also one of the part of the PM. Okay. And the third party objectives to train the operators in the correct operating procedures. As all installed plant, including pumps, tanks, tankage, or electrical systems, instrumentation is the responsibility of the operating department, or operating procedures must include safety regulations, which prohibit unauthorized access to the equipment. And this is done by means of a work permit system. Then maintenance policies and types. There is an Indian standard, the BS standard or IS standard 3811, which is a glossary for the maintenance terms used in the technology or defined technology for maintenance policies. Like health and safety policy and good quality assurance policies, maintenance policy should be also be defined to include the breakdown or corrective maintenance and preventive or planned maintenance. Then it is possible also to develop a checklist for the plant maintenance. Definitely the checklist will be there. It is seen expression in India. We could not see any maintenance policy. So if they can do the maintenance policy, so it will be easy, or we can avoid the plenty of accidents with respect to the equipment. So see, there are how the plant maintenance works. If you see plant maintenance, then could be there in a series of the consequences. Then yes, then it will go to the emergency maintenance. There are other type. Then is the work to be done or already known? Then it is easy. It must be done. Mission to be stopped. Or if you are not known the activity to be done, then is dismantling and also test necessary to be find out. Then if the examination is done well, then condition based maintenance, then it will go to the is or must mission to be stopped. If you are not found out what test to be done, then we have to go for the inspection. This is the sequence of maintenance. Sorry, it is unplanned maintenance. If you see a planned maintenance, is it a breakdown? If you say yes, then we'll have a corrective maintenance. If it is not a breakdown, then it's to prevent a breakdown. So you are doing preventive maintenance to avoid the breakdown of the machine. Then it will go to our only consumables are being replaced. If say yes, then it will go to a called as a service. If no, it will go for preventive maintenance. Then it leads to the is the work to be done already known. If you know the activity, then yes, here it will go whether the machines to be stopped or not. If at all you want to stop the mission, it will go for a shutdown maintenance. Then it is a major job or smaller job. If it is a major S, it is an overall maintenance, or if it is no, it is a small repair. Here, if you are not able to stop the mission, running maintenance. Running maintenance in the sense, will do lubrication. or some sort of inspections will do in the running condition. That is the running maintenance. This is how unplanned and planned maintenance will work. Now we'll see the main intention of any maintenance system is to identify the failure situations and by timely repair, replacement, and servicing to stop the possible failures. What is the main intention? It is not about opening up a machine. If I'm not having any work, I'll go and open one machine. I'll be sitting with that machine, not like that. To identify the failures of the machine. This activity happens certainly save the subsequent cost of damaged plant machinery, equipment, material and stoppage, time and accident cost to persons, property and environment. Therefore, maintenance costs must have due consideration and also the budgetary provisions. That's why when doing initially every year they do the budgeting for the maintenance or capital maintenance or any machineries, etc. They do budget analysis. Then these maintenance activities include running maintenance, repairs like little interruptions of to the procedures, and servicing in the sense the replacement of any consumables like lubricant oil or engine oil, including lubrication over wheeling, production assistance, adjusting mission settings, and breakdown, corrective or emergency maintenance, unscheduled repair to broken parts, and condition-based maintenance, unscheduled testing and repair based on the unused condition. Then shutdown or preventive maintenance, which is nothing but scheduled or planned or periodical testing and repair of the including servicing. Then maintenance activities may be a type of emptying, purging, cleaning, breaking of the pipes or repair, demolition, hard works, welding, hot tapping, part removal or repair and refitting. These are the some of the few activities which comes under maintenance. Okay, with this, we have done this topic. If you have any questions, you can ask. Meanwhile, I'll open the other topics so that we could able to complete this IS 107 today. That is also a small topic only. Usually we can complete. That is the topic about mostly about the work permit system. Previously, we had a detailed discussion on the complete work permit standard. Okay. The work permit for hazardous works. So previously we discussed on work permit system new standard, which is I think IS 17311. Not exactly sure the number I've referred is correct. What is the objectives? And methodology for issue of the permit. It is an execution and a termination, forcing of the hazards and arrangement for their controls, testing and certification of working atmosphere. Testing and certification in the sense it is not that you are going to give any certificate to that equipment. It is simple that you are verified the equipment. You are ensuring that the equipment is ready or the equipment is prepared well for doing the work on that equipment. And use of tools and personal protective equipment, first aid and rescue equipment, and training of workers for Such work are common factors in any type of work permit application. Its sole purpose is to save life and also avoid accidents. Then hazardous substances are many. They may be explosive, flammable, toxic, hot, or corrosive, and maybe in the form of dust, gas, vapor, steam, hot oil, etc. They pose high degree of hazards, have caused many accidents worldwide, need strict safety precautions while working with them. So hazardous substances are there many type in nature. There are different natures, like we see in explosives, toxic, corrosives, etc. etc. So we need a proper mechanism in place while handling with this kind of equipment. Then what are the other factors being common or vital part of devising any safety work permit is to concentrate on the typical hazards involved and then to apply their remedial measures. The material safety data sheet will expose the properties of the hazards. So in the sense, whenever you are doing an activity, whenever you are doing any maintenance activity, so you have to understand, is there what type of chemicals being involved for performing this activity. Then we can understand the hazards associated with that materials. Then we will understand what kind of conditions is applicable. Conditions in the sense, safety conditions. If it is in hydrocarbons, I have to do under purging condition. If it is in a corrosive substance, I have to do neutralize the equipment. All these things we will understand by seeing the MSDS of the material or chemical. Then storage process and vessel conditions can reveal their specific hazards, and due to consideration to all such hazards is necessary before advising any substance-wise work permit. So we have to ensure we have read all these things before advising anything on the activity they are performing. Then normally the hazardous works of the maintenance or modification, we need to have an work permit system. They give in detail, one like for the operations, for the equipment, or for the hazardous area. As we seen in our previous discussions, there are requester will be there, permit riser will be there, then authorization will be there. Then all these three people together, they will come for the specific place and they'll do the inspection and they start the activity. So if you see operations wise, so what kind of operations? Operations is nothing but the work or the activity.